Okay, guys, I tried to record this 8th period and then it still wouldn't work and it still wouldn't work, so I'm just recording this again for you guys. If I end up going too fast with this video, please feel free to pause it, and kind of catch up a little bit. So I'm going to kind of run through this a little bit faster than I would normally in class. So here you go. Solving systems of inequalities, and we've had inequalities before, and those are like the less than, greater than, less than or equal to, and greater than or equal to. And then we've had systems before we did yesterday where you have like more than one equation. Okay, so like down here, we have two equations at this bottom, and all we're doing is graphing them, and we are doing some different things with shading. Okay, so what's going to end up happening, for example, is we're going to have one line that maybe goes this direction, and it's a dotted line, and we'll shade above it. But then we'll have a second line, maybe it's a solid line, and we shade below it, and what's going to happen is the solution, or the solution to that is going to be the region that's double shaded, so this region over here, and that's really what we're looking at. Okay, so starting with example 1, these two equations are ready to be graphed because they have the y that's solved for. So I am going to graph one of them in blue, and the second one I'm going to graph in green. Okay, so the blue one, we start graphing him at that -4. Start at -4, and the slope is 2 over 1. So we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And I'm going to put my dots in there. And this guy, since he's just greater than, is just going to be a dotted line. And y is greater than, so I'm going to shade above him. So this is the region that I have shaded. Okay, the green line, I always caution you and tell you not to do a decimal as the slope. So we're going to switch that. Instead of having -0.5, we're going to make it -1/2 x plus 3, and we're going to graph it that way instead. Okay, so we still start at the 3 like normal, and then -1/2 means down 1 over 2, down 1 over 2. Okay, or up 1 to the left 2, and that is going to be a solid line. So I'm going to connect my dots, and y is less than, so I'm going to shade below. Okay, so the region that's the solution is going to be anything that's in this region here. So when you're doing this on your homework assignment, I give you a worksheet, so make sure you have a copy of that, and we do the odds on both sides. Your solution region is going to be shaded in really dark, so make sure that you have them shaded in really dark. And really what that solution region means is that any number or any ordered pair, like any xy coordinate in that region, will be a solution to these two guys. So like, let's say -1, 2 is like a point that lives there, or -6, -3 would be a point that lives there, right? Any of those would work if I plug them into those equations, as long as it's in that solution shaded region. Okay, all right, let's go down to this next one. And next we have two equations that are ready to be graphed again. So I'm going to do one in blue, one in green. The top one, the blue one, we still start him at 5, and the slope is up 1 over 1. So we're going to go up 1 over 1, up 1 over 1, down 1, left 1, and he looks like that. Okay, and he is a solid line, so I'm going to fill him in, and y is greater than, so I'm going to shade him above. Okay, again, if I'm going too fast, please pause. All right, the second one is at -4, and the slope is up 1 over 1 again, so up 1 over 1, up 1 over 1, and you might be able to tell that by looking at those two equations. Oh, this is a dotted line. Just by looking at those two equations, we notice that they have the same slope. So they're going to be parallel, right? And they are parallel. This bottom one, though, we're shading below it. Okay, so sometimes you'll have what's called separate regions, and what we're really looking for when we're shading these is the region that's doubly shaded. Well, there's no region here that's double shaded, which means there's not one ordered pair that will be sufficient for this area and for this area. So in that case, we say we have no solution. There's not one solution that works with the top shaded region and the bottom shaded region as well. Okay, so no solution there. All right, example 3, we have to write out our system of inequalities before we graph them. Okay, so let's just go through and kind of pick this story problem apart. Chelsea has final exams in calculus, physics, and history, so 3 different classes that we have. She has up to 25 hours to study for the exams, all right? She plans to study history for 2 hours. Okay, so that kind of knocks out history. We already know that history is 2, and he's basically done. But that gives us a little bit more information because that means we have calculus and physics together. The numbers of hours spent on calculus plus the number of hours spent on physics has to be something less than or equal to 23 in this case, because 25 total, 2 hours spent on history. That means we have 23 hours left, okay? So we're up to this point here, we've gotten that information all done, and we already have one inequality ready to go. Okay, this next piece, she needs to spend at least 7 hours studying for calculus. So that tells me that calculus has to be greater than or equal to 7. But then it says, but over 14 is too much. So we also know that calculus has to be less than or equal to 14 hours. Okay, and now that part is done. Let's go to the last thing. It says she hopes to spend between 8 and 12 hours on physics. Okay, so that means that physics has to be greater than or equal to 8, but also physics can be is less than or equal to 12. Okay, and so really we have like 5 different equations that we have to graph here, which is kind of crazy, but you know, they're not too bad. The bottom 4 equations are actually pretty easy to graph, okay? Now, history we don't have to worry about because he's all done, because the only things that we're worried about is calculus and physics, okay? And physics, since it's on the x-axis and calculus is on the y-axis, that's kind of how those variables operate. So physics is going to be like an x variable, and calculus is going to be like a y variable. So y and x and all that good stuff, okay? All right, again, if I'm going too fast, please pause. Okay, I'm going to start from the bottom equation and work up to the top. So let's start with this one first. This is kind of like saying x is less than or equal to 12, okay? And whenever you have just one variable, you're only ever going to have a straight up and down line or a straight horizontal line. So this is what it will look like when only one variable. Okay, like I only have an x or I only have a y in the equation, like this one, right? That's only x. There's no y at all. Really, all of these equations have only x or y and not the other variable. This top equation is the only one that I have an x and a y together. So these last 4 are just going to be either vertical lines or horizontal lines, and they're not going to have a slant to them. Okay, so this last one, x is less than or equal to 12, this guy that we're graphing here. We go over to 12 on the x, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to mark 12 there, and he's going to be straight up and down line, okay, on 12, and he's a solid line because he's solid, and P is less than that, so we're shading below 12, okay? Then the next one, P is greater than 8, so I'm going to go to 8, and 8 is 4 below 12, so about right there is where 8 is. And I'm going to shade him, and he looks like that, and we're shading above him because P is greater than 8. So really, the region that we have double shaded at this point, I'm going to get rid of those. The region that's double shaded at this point is just this region inside of here. Okay, now let's go to the blue ones. These are the C's. C has to be between 7 and 14, okay? So I have, let's start with the 14 one. C is less than 14, and C is the y variable. So we go to the y-axis, and we go to 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 is about right there on the y-axis, and I make him a straight horizontal line this time. And we're going to shade him below because C is less than that, okay? And then C has to be greater than 7. So 1, 2, 3, 4, 5, 6, 7. This is where he is right there. That's at 7. And we're going to shade him above. So the region there that's like 4 times shaded, I guess, is not that, and not even, and not even this guy anymore. It is just the region that's shaded inside of here because we've enclosed kind of that rectangular area. Okay, and then the last thing is C plus P is less than or equal to 23. Okay, so our C variable is really like the y. So normally we have to get y solved for. So we're going to kick the P to the other side. We're going to subtract P. And we end up with, I'm going to run out of room here. I'm going to write it over here. We end up with C is less than or equal to negative P plus 23. Okay, and that's the last thing that we're going to graph. So we're going to start on the y-axis. I'm going to graph this in purple here. Start at the y-axis at 23, and the slope says down 1 over 1. Okay, so we're starting at 23. Here's where 14 is. 15, 16, 17, 18, 19, 20, 21, 22, 23, something like that, right there in the middle, okay? And we're going down 1 over 1, down 1 over 1, down 1 over 1, all the way through. And really, if I do this, and we're up here at 23, and I keep going down 1 over 1, what we're going to do is we're going to end up in the same spot at the bottom at a positive 23 here. And then I can just connect those two dots like that, okay? And the region that we're shading is less than. C is less than. So we're going to shade below. So now our final region that we have shaded is just this area inside of here, okay? So any combinations of calculus and physics that are in this region will work. Like, let's say 10 hours of calculus and 9 hours of physics. Or no, excuse me, 10 hours of physics, 9 hours of calculus. This would be the point 10, 9. So 10 physics, 9 calculus. That's an example of a combination that would work. Okay? All right, let's go to the back side. And now they have 3 things that they want us to graph. Here's the first equation. And I've put that down here below. I've just rewritten it, but in yellow or orange, whatever color that is. And the second one is purple. I've written it there. And the third one I've put in green, and it's this guy here, okay? And 2 of those are ready to graph. The third one is not. So we're going to divide the third one by 4 and get him simplified. And we have y is greater than or equal to. 15 over 4 won't reduce, so we'll just leave him as negative 15 over 4x and minus 8. If I'm going too fast, make sure you pause. Okay, now we're just going to graph each one of these. So I'm going to start with the top one. The top one is this yellowish golden color one. And we're going to start him at negative 8, which is this dot right here. And the slope is up 2 over 1, up 2 over 1, up 2 over 1. And he is a solid line. So we're going to start and we're going to make a solid line, and it looks like that. Okay. The second one, y is less than or equal to negative 1/4 x plus 6. We start at positive 6, 2, 4, 6 right below it. And we go down 1 over 4 and down 1 over 4. Or up 1 to the left 4, up 1 to the left 4. And we make our dotted line. Or excuse me, it's not a dotted line, it's a solid line. And that's what he looks like. And then the last one, the green one, we start at negative 8. That's this guy right here. Start at negative 8. And we go down 15 over 4. If we go down 15 and over 4, we're going to end up way over here. Okay, so instead of doing that, we're going to go up 15 and to the left 4. So if we're starting at negative 8 and we go up 15, that's going to land us at 7, right? Negative 8 plus 15 is at 7. And we go over 4, oh man, we're going to land right on top of this dot right here. So we have them connecting really nice, really nice. Oh, and I forgot to shade. Forgot to shade any of these. But when we shade, what's going to happen is you can check to make sure. But when we shade, we're going to shade all of those regions together, which is just going to enclose that triangle there. And what they're asking for isn't just to shade. They're saying find the coordinates of the vertices. And vertices are just the corner points. So like, where is this thing located? Where is that one located? Where is that one located? And we just have to label them, okay? Now, this is where the tricky part comes in, because 2 of them are really nice, 1 of them is not. So this coordinate, the top left, this guy, is really nice. He's at negative 4, 7. Okay, the bottom guy is at 0, negative 8. But this one over here, we don't quite know because he's kind of like in the middle and we can't really see him very well. So if we think about it, this place right here is where 2 lines are crossing each other. Wouldn't it be really nice if we had a method for finding where 2 lines cross each other? Oh, wait a second. That's what we were doing yesterday, right? We were doing the substitution and elimination method. So we're just looking at the golden line and the purple line, those 2 guys, and we're trying to figure out where they cross each other. So those 2 things, we're going to use substitution or elimination to find where they cross, okay? So I'm going to rewrite those down below. This kind of feels like a lot of work, and it is a little bit. I'm going to write him down below. But rather than writing greater than or equal to, I'm just going to write equal to, because I don't want to get bogged down with the greater than, less than, whatever. We're just trying to find where they intersect. So I'm just going to change those to equal to. Okay, so we've got those 2 equations. We're trying to figure out where they are equal to. Okay, so we get to decide whether we want to use substitution or elimination. Okay, so substitution would work kind of nice. because we know that y is equal to 2x minus 8, and all I have to do is lump the 2x minus 8 into that y. Or, elimination would work really nicely because we have the y's that we can cancel out. We just have to make one of them negative. So let's do that method. Let's go ahead and make the y negative, which means we have to flip the sign here, and this 6 is going to now be negative instead. And we're just going to add those two together. So the y's are going to cancel out, so we'll have 0 left over here. And then 2x plus a fourth x is 2 1/4, but I'm going to end up dividing that. So I'm going to change it to a decimal and make it 2.25x, okay? And then negative 8 and negative 6 is negative 14, okay? Then the last thing, I'm going to add 14. So I have 14 equals 2.25x. And if we divide by 2.25, 2.5, x will be 6.2 repeating, or 6 2/9. 6.2 repeating. That's the x variable. But then we have to find y. Okay, so we want to plug 6.2 in for x, and I want to plug them into this top equation just because I don't like fractions. This would give me a fraction. I don't want to do that. So y equals 2 times, and 6.2 repeating, if you don't have it saved already in your calculator, let's just plug in 6.2222. We'll just do a handful of 2's, right? And then minus 8, okay? Well, 2 times 6.2 repeating is going to be 12.444444, right? And then if we subtract 8 from that, 12 minus 8 is just going to be 4.44444. So really that's like 4.4 repeating. Okay, and that's what y is. And we're done now. Let's just put it all together and, summarize. So the x-coordinate is 6.2 repeating. The y-coordinate is 4.4 repeating. That means this spot up here, we know it now. We can erase the question mark. And this dot right here is 6.2 repeating, comma 4.4 repeating, which I probably wouldn't have guessed if I had to just do that on my own, I wouldn't have guessed that that's that decimal place. But it does kind of look like it's over 6.2-ish and up 4.4-ish. So that's pretty good. Okay, so the homework assignment is a worksheet. If you don't have that from me, you need to get it. And we will do the odds on both sides. So 1, 3, 5, 7, whatever, on both sides. Okay?